Welcome, everyone, to the Foundry by Forge College. I'm your host, and I'm absolutely thrilled to guide you through today's explainer, which is an introduction to Cloudbreak integration. Now, you might remember in our last lesson, we covered the use cases, basically the incredible advantages of decoupling massive state storage from our on-chain accounts. Well, today, we're taking that theory and turning it into a practical assembly guide. We're moving from why Cloudbreak helps it scale to exactly how you build it into your real-world Solana applications. Let's get into it. Okay, let's dive into this. Here is our technical schematic for today. We'll start with a blueprint orientation, look at the core architectural components, and explain the integration patterns. Then, we'll cover smart partitioning strategies, walk through the 6 steps to integration, and wrap up with quality assurance. All right, Section 1, the blueprint orientation, taking this from theory to assembly. To really wrap our heads around this, it helps to think of your application state like a massive distributed library. It's got 2 completely distinct environments. On one side, you have your on-chain state. Think of this as the central registry. It's compact, it's strictly consensus verified, and it holds the definitive legal title records of who owns which book. But listen, trying to cram every single piece of read-heavy application data into the central registry, it's literally like packing thousands of highly caffeinated, stressed-out readers into a tiny, single-room archive. It gets crowded and expensive really fast. So, on the other side, we have our Cloudbreak state. These are the physical archives. It's a horizontally scalable, expansive network that stores the actual books and heavy indexes your users are interacting with all the time. Moving on to Section 2, core architectural components. Let's talk about the materials. Connecting these 2 environments requires some active, moving parts, and this brilliantly illustrates our librarians and conveyor belts. Our RPC nodes and indexers, they act as our librarians. They know exactly where to find material across all those archive branches. Meanwhile, our asynchronous sync workers act as the conveyor belts. So whenever a new on-chain write happens, these workers shuttle the updated material right over to the Cloudbreak archives. The catch? Well, if your conveyor belt stalls, your reading room ends up handing out stale, outdated copies. We definitely don't want that. Section 3, integration patterns explained. These are our assembly methods. You basically have 3 main choices here depending on what your app needs. Number 1 is synchronous fetch on demand. This is where your program or RPC node reads Cloudbreak right at the exact time of the request. It's great because it minimizes the headache of eventual consistency, but it does increase tail latency since you're fetching data in real time. Number 2 is asynchronous synchronization. This drastically lowers latency for your clients, but, and it's a big but, it requires robust, active reconciliation to make sure your users aren't reading stale data. And finally, number 3 is the cache-first approach. Here, RPC nodes maintain local caches that are warmed directly from Cloudbreak for ultra-low latency reads. So, you implement one of these patterns, everything seems fine, and then suddenly, your users are asking, hey, why is my query so slow? This is exactly where our library metaphor becomes an incredible tool for diagnosing our mechanical system. When things slow down, you're usually looking at one of 3 things. First, shelving issues. This essentially means you have a poor partition mapping. Think about it. If you've scattered all the sports books across 10 different physical branches, your librarians have to make a bunch of cross-shard network hops, which just kills performance. Second, conveyor jams. This means your sync workers are lagging, so the time between an on-chain event and a Cloudbreak update is dragging. And third, reading room congestion. This points directly to insufficient RPC caching capacity. Section 4, smart partitioning strategies. Let's look at the technical trade-offs. To prevent those frustrating shelving issues we just talked about, you really have to calculate 4 main integration concerns for your blueprint. First up, access pattern. Are you read-heavy or write-heavy? If you're read-heavy with wide-range queries, you absolutely must design your partition keys to localize reads. Second, consistency requirements. If you need strong read-after-write consistency, those authoritative fields have to stay strictly on-chain. Third, key derivation. This dictates exactly how your Cloudbreak keys map to your on-chain accounts. And finally, operational visibility. You have to instrument your RPC in Cloudbreak with correlated metrics, otherwise you're just flying blind. So the crucial point here is this concept of deterministic key derivation. It is the golden rule of shelving. Your librarians, meaning any node or service, must be able to compute exactly where a Cloudbreak key belongs entirely independently. No phoning a friend, no consulting a third-party indexer. This dramatically reduces system coupling, and honestly, it makes disaster recovery so much simpler because you can rebuild your indexes directly from the ledger history. Section 5. 6 Steps to Integration. This is the actual construction process. Learning to master blueprints like this is exactly the kind of deep dive we do at Forge College. Step 1 is defining your scope and your invariants. You want to start by profiling your application's access patterns so you know exactly what needs to stay on-chain. Step 2 is mapping that profile to one of the integration patterns we discussed, sync, async, or cache first. Then, Step 3 is designing your key derivation and simulating your partition keys. You'll want to run a realistic request trace and look out for hot partitions. If you spot them, you might need to use multidimensional keys, like, say, combining a user ID with a time bucket, just to spread that load out. Now, while you're defining your scope in Step 1, you absolutely must write down your strict invariants. For example, balance verifications must use on-chain authoritative amounts. This is absolutely crucial. Security, access control, encryption, data integrity, these are never abstract afterthoughts in your rollout. If consensus data is required, it stays on-chain, period. Let's move to and see how this builds out the rest of the way. Step 4 requires building your instrumentation before you go live. Add your metrics for sync, latency, queue depth, error rates. Step 5 is executing a staged canary rollout. Route a small percentage of traffic to Cloudbreak and validate it against A/B comparisons. Finally, Step 6 is operationalizing your maintenance. Plan out reversible schema migrations and set up disaster recovery workflows so you're never caught off guard. Section 6, Quality Assurance. How we actually measure success. You simply cannot just bolt Cloudbreak onto your stack blindly. You need to look at your application's access patterns for real empirical signals. For instance, if your profiling reveals a high volume of large paginated range reads, that is a massive flashing green light telling you to move that collection into Cloudbreak. Now, what's really interesting about this slide is seeing what good actually looks like after a successful canary test. You want to see a clear, measurable drop in your cost per read. You want to see stable sync latency that fits right within your SLA. Because if your cache hit rate drops below your threshold, or if tail latency randomly spikes, your instrumentation should tell you immediately so you can revert and investigate. At the end of the day, integrating Cloudbreak is so much more than just a simple storage swap. It demands correlated observability across your on-chain events and off-chain state. So I'll leave you with this question. Are your librarians ready for tomorrow's scale? By tying your architectural design directly to observable metrics right from day one, you ensure your integration will actually hit your latency and cost targets. Thank you so much for joining me for this explainer. I really encourage you to visit our platform at 4g.college to explore more content, dive deeper into Web3 architecture, and keep building the future. See you next time.